Hello, this is Dr. Luke's, Chapter 18, Multi-Loop and Multivariable Control. We are going to, in this video lesson, look at stability and a very quick guidance on tuning multiple input, multiple output systems. Now I'm going to very briefly discuss tuning multi-loop PID control systems. This is really mostly based on what we did back in Chapter 12 for the single input, single output feedback control loops. And we have 4 basic methods. You can read more about these, but for now, okay, we have 4 things: detuning, sequential loop tuning, and independent loop tuning, and then relay auto tuning. So detuning basically says, okay, those interactions, they can be a problem. So what they recommend is that you start by just tune the loops the way you would have back in Chapter 12, okay? Use the MIMO method, whatever you need to. Go back and use a basic technique, find your best tuning parameters, okay? And just set those as your values for each of your loops, as if they had no interactions. Well, we know that there probably are interactions. And so if the interactions are a problem, if doing the basic Chapter 12 stuff didn't cut it, then you're going to add a detuning factor. Now, this is a number typically between 1.5 and 4, okay? The larger the value, the more stable the system will be. However, it's going to really slow down the response, okay? So, depends on, exactly what the issues were, why you didn't like just tuning them all separately. Once you choose that detuning factor, all you're going to do is take your KC that you had for each one of your loops and divide that by your detuning factor, okay? And your tau I, you're going to multiply by your detuning factor. So tau I is going to increase, KC is going to decrease. And you just do that and go with it, and it's probably not too terrible, okay? So that's detuning. Sequential loop tuning and independent loop tuning are in some respects very much the same. Basically, the idea is you just tune a loop, okay? Figure out which loop you're going to start with and tune it. And then leave it on and tune the next loop. And do that all the way through all of your loops, okay? Now, the first one you could design using the techniques of Chapter 12. For the second, third, however many these you have, that's not really going to work quite so well. So it's going to be much more use your instincts or trial and error to be able to come up with the tuning. So what do people really do? Honestly, mostly they do auto-tuning. Multi-input, multi-output systems are generally going to be tuned by the computers, okay? And that's called auto-tuning. As a final topic, I want to talk about decoupling. So when the interactions between the variables are just really large and they are causing stability issues, you're not able to get a very functional control system, we can add in a decoupler and it can reduce the interaction. So what I'm going to do, now remember that normally I would be this, if I'm controlling Y1 by changing U1, I would be, my primary loop would be this one. And I similarly would have this one down here for U2 to Y2. But keep in mind that I also had that hidden loop that was, if I went through this loop, but I remember that U1 also affects Y2. And Y2, oops, there we go, also affects U2. And so I had that hidden loop there. So what I can do is I can kind of take the sting out of this by creating yet another loop. And this time, I'm going to go through my loop like I was normally, but after the controller, before the valve, what I'm going to do is I am going to change U2, which is going to change Y2. And then controller 2 is going to change U1, which will affect Y1. But I can do that, and I can make choices of transfer functions so that I minimize the effect of the GP12 and GP21. So I can minimize the interactions. I'm not going to be able to totally eliminate them, but I can certainly make it less. All right, that's called decoupling. It does reduce interactions. I mean, mathematically, it just, if you design it right, it has to decrease the interaction. However, that doesn't necessarily mean it's going to make the control loop work any better. Okay, but you will see this done. So this is what's called decoupling. So this wraps up all of the material on multi-input, multi-output control systems. We'll do one last video, and that one will just work another problem. Okay, thank you.